It was a late night for some of us, as Crew 4 returned from the International Space Station. More on that in a few.
But first, we're going to start out the show with rocks from space!
And we'll take a look at some ways researchers are trying to narrow down places to look for life beyond Earth.
Then there's this really shy star that was hiding in the bright flash of its companion supernova.
Last but not least, I've got another lens review for you this week.
All of this and more is coming to you right here on The Daily Space. I'm your host, Dr. Pamela Gay.
And I'm your host, Eric Mattis.
And we're here to put science in your brain. Let's kick this news off with a bang, literally. Last week, on April 27th, posts about a fireball seen over parts of the southern U.S. began taking over social media. People reported loud booms and bright lights, and they submitted their reports to the American Meteor Society's Fireball Tracking website. Then, just 3 days later, meteorite hunters began finding the fragments of the fireball on the ground. Fireball researcher Erik Rasmussen looked over weather radar data recorded at the time of the explosion and discovered a cloud that appeared and disappeared at the end of the fireball's path. Meteorite expert Mark Fries was brought in, and they determined that the cloud was evidence of the meteorite's actual landing. On April 30th, Mark and his wife Linda set out on a short road trip to the possible site, and during the afternoon, she found the first fragment. Mark found another, and they were only 2 of the meteorites recovered prior to rainstorms over the weekend. Now that more meteorite hunters have joined the search, at least 3 more fragments have been found. Unfortunately, most of the fall seems to have occurred over a densely wooded area, so the meteorites located have been near the roads, and from the looks of the meteorites, they're just ordinary chondrites. Congratulations to all those lucky meteorite hounds. Enjoy your space rocks. Speaking of space rocks, here's some news about moon rocks. No, not quantum tunnel conducting moon rocks, but frozen runs. During 1972's Apollo 17 mission, astronauts collected lots of different types of rocks. When they came back to Earth, some of the rocks were frozen to preserve volatile gases and other substances which may be in them. Other rocks remained at room temperature for comparison. Now, in 2022, scientists are taking these rocks out of the freezer, part of an overall goal to help NASA's return to the moon with the Artemis program. The first step in this 4-year-long process was to make a facility to process the special cold rocks for distribution to other researchers. Another problem was with the scientists working at the new facility. The cold facility requires a glove box, which is challenging to use. The cold temperatures also produce frost, which limits visibility. The development of the facility will also help prepare equipment for returning cold samples by the Artemis missions. As for the types of research being done, Jamie Aslina, a research scientist at NASA Goddard, is looking for amino acids in the frozen rock. The team hopes to find out how they got there and where they might be in the rest of the solar system. As Alina said, our research goal is to identify and quantify these small organic volatile compounds, as well as any amino acids, and use the data to understand the prebiotic organic chemistry of the moon. End quote. Another team also got access to the frozen moon rocks. Specifically, this team hopes to use the relatively unchanging noble gases to understand changes to any organic material in the rocks. Both of these teams will compare their frozen samples with the room temperature ones. And now for something entirely different. Humans returning to Earth.
This morning, April 6th, at around 0445 UTC, SpaceX's Dragon C-210, more commonly called Endurance, brought the 4 crew members of NASA's Crew 3 mission safely back to Earth. Undocking was the previous evening, May 5th, and the astronauts configured the capsule for return. The deorbit burn was 15 minutes long as usual, and as the capsule re-entered the atmosphere, it experienced the standard plasma blackout. Dragon Endurance emerged from the plasma blackout on schedule, and drogue and main parachute deployment were completely nominal. After splashdown, the capsule was lifted onto the recovery vessel Shannon, named after Shannon Walker, one of the Crew 1 astronauts. From there, the 4 astronauts, Commander Rajachari, Kayla Barron, Thomas Marshburn, and Matthias Maurer, were helped from the capsule and after a brief medical checkup, flown in a helicopter back to land. Raja, Thomas, and Kayla were flown to Houston for post-mission activities, and Matthias boarded a plane back to Germany for the same. The Crew 3 return comes a week after Crew 4 was launched to the International Space Station, which was itself a few days after the return of the AX-1 mission. A busy few weeks for the ISS program and SpaceX. That's enough about rocks and returns to Earth. It's time to share stories about exoplanets, extraterrestrial oceans, and a supernova. Stay tuned.
A lot of time has been spent talking about the so-called Goldilocks zone when it comes to the search for Earth 2.0. The Kepler mission was designed basically to do just that. Stare at stars similar to our sun and look for rocky planets in that region where liquid water could exist. But we still haven't found an exoplanet that matches our conditions. And it's not even about the possibility of liquid water anymore. After all, we have liquid water beneath icy crusts on worlds in our solar system that definitely aren't in the Goldilocks zone. So now, researchers at the Southwest Research Institute have led new work on narrowing down candidates for other Earths. Their results were published in the astrophysical journal Letters. And the reason that younger planets make better targets is because they still have the right amounts of radioactive isotopes to keep the planet warm. And that would happen through a process called mantle degassing, where the radioactive heat causes convection in the mantle, and that convection allows carbon dioxide to vent from volcanoes. A carbon dioxide blanket would warm the planet, and that could help support a habitable climate. Of course, determining if an exoplanet has the right abundance of elements is difficult, especially considering we're just starting to grasp what the atmospheres are made of. But we can spectroscopically measure the host star to determine what elements are in the outer layers, and from there, infer the composition of the planets. Again, we'll need younger planets for this type of heating. As lead author Cayman Uterborn explains, quote, under the most pessimistic conditions, we estimate this critical age is only around 2 billion years old for an Earth-mass planet and reaching 5 to 6 billion years for higher-mass planets under more optimistic conditions. For the few planets we do have ages for, we found only a few were young enough for us to confidently say they can have surface degassing of carbon today. End quote. The team is hoping that a certain newly aligned space telescope will help provide some more data in our quest for Earth 2.0. I mentioned icy worlds in our solar system and how they have liquid water under those icy shells. These worlds include the likes of Europa, Ganymede, Titan, and Enceladus, and it turns out they make Earth look dry. Now, in a new paper published in the journal Cell Reports Physical Sciences, a team of researchers has provided possible temperature ranges for keeping all that water in its liquid form. That's sort of key for developing life beneath the surface, after all. Co-author Baptiste Journac explains, quote, The more a liquid is stable, the more promising it is for habitability. Our results show that the cold, salty, high-pressure liquids found in the deep oceans of other planets' moons can remain liquid to a much cooler temperature than they would at lower pressures. This extends the range of possible habitats on icy moons and will allow us to pinpoint where we should be, where we should look for biosignatures or signs of life." End quote. The team ran experiments to find just where the lowest temperature of various saltwater solutions was, where the solution was still liquid. Saltwater can stay liquid at lower temperatures, as those of you living in places with winter and snow and ice can attest to every time you sprinkle salt on your driveway. On top of using salty solutions, the experiments upped the atmospheric pressure to 300 megapascals, about 3 times the pressure found in the Marianas Trench. It turns out that increasing the pressure is more important than changing up the mixture, as the lowest possible temperature shifted similarly across the different solutions. Co-author and team lead Matthew Powell-Palm explains, quote, "This similarity further revealed that the response to pressure of the minimum temperature for a liquid to exist is mainly controlled by the ice and is relatively insensitive to the behavior of the other solid salt phase. This provides an invaluable and fundamental rule of thumb for future compositional modeling of different solutes and solutions. The pressure dependence of the minimum temperature may be roughly approximated by the pressure dependence of the melting point of pure ice." End quote. With so many missions scheduled to head to these icy worlds in the next decade or so, we may soon have a chance to test these results in situ with landers and probes. We'll keep you all up to date on these missions as they happen. One of the first things you realize when studying astronomy is that our universe is way more dangerous of a place than your standard episode of Star Trek may imply. That journey to strange new worlds? It's likely to get interrupted by stellar events that go boom, flare, or irradiate in the night. Oh, and we'll review Strange New Worlds next week. In today's installation of How Stars Harm One Another, we have the tale of the star that was left behind when its companion exploded. Back in 2013, a supernova went off in the nearby galaxy NGC 3287. The initial burst saturated the scene, but as the light of the supernova faded, a small source of ultraviolet became visible, and that small glow appears to be a companion star. This particular supernova wasn't rich in hydrogen, and it had previously been assumed that the original star had blown away its hydrogen gas atmosphere. If this was the case, over time, light from the supernova would allow us to see that cloud of hydrogen. But that didn't happen. Now, researchers are looking at this companion and thinking, it just might be the hydrogen thief, and thinking that this kind of gassy robbery may be happening on a regular basis throughout our universe. According to researcher Maria Drought, in recent years, many different lines of evidence have told us that stripped supernovae are likely formed in binaries, but we had yet to actually see the companion. So much of the studying of cosmic explosions is like forensic science, searching for clues and seeing what theories match. Thanks to Hubble, we are able to see all of this directly. Today, this system consists of either a neutron star or a black hole that was left behind by the supernova, and this bright ultraviolet companion, which is also a massive star and which will also one day explode. Maybe. The exact future of the system is tied to the distance between that surviving star and the remnant of the supernova. Too close? They merge. Too far? Nah, they just fly apart. That coming together, that is what we want to see. As researcher Ori Fox explains, quote, "With the surviving companion of supernova 2013 GE, we could potentially be seeing the prequel to a gravitational wave event." End quote. Yes, folks. If these stellar remnants merge, it will literally expand and contract our world in a detectable gravitational wave. Fox does add, quote, "Such an event would still be about 1 billion years in the future," end quote. Folks, there is no reason to stay up waiting for this merger. But it is cool to know we are seeing the start of the kind of event LIGO is letting us catch at the end. Now we just need to find a way not to skip over the middle. Hubble isn't available for most of us to use for our astroimaging, but there are some amazing backyard cameras that work for day and night. Up next, Eric reviews the Canon RF 24-105 STM lens. Stay tuned.
This week, we bring you a review of a Canon full-frame mirrorless mount lens, the all-in-one RF 24-105 IS STM. And for those of you wondering what a mirrorless camera is, it's just a fancy way of saying that engineers figured out how to get rid of the mirror that was used to bounce light to either a viewfinder or a sensor. Now, in our digital era, everything just goes straight to a sensor and a small screen that acts as a viewfinder. With that mirror gone, these cameras weigh less, are smaller, and are actually a little bit more effective at collecting light when everything is equal, which it really never is. So, let's go with this type of camera is lighter and smaller than your standard DSLR camera. And as for this RF lens, well, Canon carries two lines of lenses, RF and EF. If you have older Canon lenses for film or digital camera bodies, they're probably EF. The RF lenses are for the full-frame mirrorless cameras only. Canon has another mount for crop mirrorless, but we don't need to get into that. That's it. No more fancy acronyms. And now to actually review the lens. I tested the Canon RF 24-105mm IS STM on my R6. Build quality wise, this lens is good. Like many lenses today, the outside is plastic, while the lens mount is, of course, metal. Because it's so small, the lens does not have room for separate focus and control rings, so they are combined. The zoom ring takes up most of the lens's length, and is grippy and close to the camera body for ease of access. It moves smoothly, though it is a little stiffer at the telephoto end. The control ring has a different texture, so you can tell which one you are using, even through gloves. It has two switches on the side, one for the control/manual focus ring, and the other for turning on or off the optical stabilization. Mounted on my R6, the lens balances quite nicely. However, on the Canon RP I used to own, it was somewhat uncomfortable because the weight was balanced toward the lens. On the other hand, with either body, the total system is light enough so that I was able to use a simple wrist strap rather than having it around my neck, improving portability without fatigue. Fitting a body with a lens on it and a neck strap in one of my small camera bags has been a problem, solved by this lens and a neck strap. The compromise to having such a small, light, inexpensive lens is a non-constant aperture range of f4 at 24mm to f7.1 at 105mm, a full 2/3 of a stop slower than the EF equivalent. This means that you'll need a longer exposure time to get the same photo. This lens has optical stabilization, so longer exposures are easy. The R6 has sensor stabilization as well, further increasing the long exposure performance of this lens. For folks capturing motion, these longer exposures could be a problem. You could compensate with a higher ISO speed, if you don't mind noise. And for some, especially hikers and people out walking, this lens's smaller size will matter more than the visually hard to see added noise. Image quality was decent, but this lens definitely works best in the middle of its focal range, with the image decaying at the extreme widest and longest. Lens corrections cleaned up distortions nicely. I did notice a little color fringing even with those corrections, but it was gone by 50mm. These corrections can be applied in camera, making it easy to get good images. One of the mirrorless specific features of this lens is a higher reproduction ratio of 1:2 compared to the 1:3 of the EF equivalent. Put another way, if you focus just right on an object 54mm long, it will fill the frame. In this mode, the minimum focus distance is then reduced to about an inch from the front of the lens. And if you can get your camera to within 1 inch of a living bug, it makes for an amazing shot. Good luck not scaring the bug though. For those of you who want more in-depth info on this lens's more eclectic features, I have a longer review on Medium. Links are available on dailyspace.org. Overall, this is a nice, small, all-in-one lens that you can tuck away in the corner of your camera bag for when you need a shorter focal-length lens, or carry it in your hand when you just want to go on a walk about in search of a not-scared bug. It is perhaps a bit expensive at $400, but you can buy refurbished ones from Canon for $250. Enjoy the spring with your camera. Look up, look down, and remember, all of it is held together by the same science. This has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.